Hello, this is Reed Tillery, and in this video we want to look at understanding latitude and longitude. Latitude and longitude lines on the Earth are imaginary vertical and horizontal lines that form what's called the lat-long grid. You can see here on this nice blue Earth we have some longitude lines. I'll just draw a line down here to try to outline that particular longitude line. That is a north-south line that runs from the North Pole down to the South Pole. And all longitude lines run from the North Pole to the South Pole, which means essentially that they converge up here at the poles. So all of these longitude and latitude lines converge at the poles. All of these longitude lines converge at the poles. But the latitude lines, they don't converge. I'll just outline this latitude line here. Still learning to use this software, so this little electronic pen is kind of tricky to work with. This latitude line, like all latitude lines, are a series of parallel rings around the Earth, and they never converge, but they do run parallel. In fact, the longitude lines, another name for longitude lines, are meridians. So the line that I have outlined here is a meridian of longitude, and then the line that I have outlined, the east-west line that I've outlined, is a parallel of latitude. So meridians, longitude lines are meridians, and latitude lines are parallels, which is another name for it. Now, if we look at the values that you give to lat-long lines, let's look first at longitude. Longitude lines start, the values for longitude lines start at what's called the prime meridian. I'll come right over here and write prime meridian. It's hard to read this old left-handed writing, but we'll go right here, and there's the prime meridian, and the prime meridian runs through, I don't know, I guess it's about right here, runs through a place called Greenwich, England. Some other countries do have a different prime meridian that runs through other places, but most of the time Greenwich, England is the prime meridian for the lat-long grid. So right here, Greenwich, England, the prime meridian runs right through there, and at Greenwich the longitude is 0 degrees. Now when you leave Greenwich and go to the east, longitude increases all the way around to the back part of the Earth. It increases from 0 to 180 degrees, and this is east longitude, east of Greenwich. And then west of Greenwich, the longitude increases from 0 to 180 degrees also, and this is west longitude. So back here at the international date line, which is on the opposite side of the Earth from Greenwich, England, the longitude is 180 degrees east and also 180 degrees west. So at the international date line is, you might say, where east meets west. And these values here then are somewhere, the value of these longitude lines are somewhere between 0 and 180. This might be, oh, I don't know, we'll say that might be 20 degrees. And usually we'll put a little leading 0, so a navigator, rather than saying 20 degrees west longitude, might say 020 degrees, because since there are 180 degrees of longitude, that means there are 3 places, and if you only have 2 places, like in 20 degrees, you need a placeholder, a leading 0 there to be a placeholder. Latitude, on the other hand, starts at the equator, and this latitude line that I've highlighted here is the equator. And it starts at the equator and it runs all the way down to the South Pole, where the latitude is 90 degrees south. And it also runs all the way up to the North Pole, all the way up here where the latitude is 90 degrees north. So latitude runs from 0 to 90 degrees, either north or south, and longitude runs 0 to 180 degrees, either east or west. Latitude and longitude lines then form something that are like streets and avenues, imaginary streets and avenues around the world. Instead of, if you want to state your position or tell where you are, you would give the coordinate, and the lat long coordinate. You'd give the lat long coordinate. And you would do that by stating which particular longitude line you were on and which particular latitude line you were on. In the same way that if you were in a city and you said, I'm at the intersection of 39th Avenue and 13th Street, in the lat long grid, you might say I'm at 20 degrees north and 080 degrees west. You notice I state the degrees and then I state the hemisphere. Sometimes you can put the hemisphere first, so a coordinate might be stated as north 20 degrees, west 80 degrees, or north 20 degrees, west 080 degrees. So you can put the hemisphere either first or second. In my experience, most people tend to put the hemisphere after the number of degrees. But unless you're on one of these major even lines like 20 degrees or 80 degrees, you're most likely to be somewhere in the middle, so that is not precise enough at all. So we need to have more precision in how we state the coordinates, and the way that's worked out is that degrees are divided just working with this software here, it's a little tricky. Degrees are divided into 60 minutes. And minutes, don't jump around on me here, screen. Minutes are divided into 60 seconds. A degree of latitude, 1 degree of latitude equals approximately 60 nautical miles. So if 1 degree of latitude equals 60 nautical miles, then 1 minute of latitude equals approximately 1 nautical mile. And since there are 6,000 feet, more or less, in a nautical mile, if we divide that by 60, then 1 second of latitude equals about 100 feet. So a coordinate that is expressed in degrees, minutes, and seconds is accurate down to about 100 feet. So let's look at a particular coordinate. Let's say that we are at, let me just draw a line under here to come down here. Let's say we are at 20 degrees 32 minutes and 10 seconds north, and 080 degrees 15 minutes and 27 seconds west. So here is our coordinate given in degrees, minutes, and seconds. So that is a common way of stating a GPS or a lat-long coordinate. But there is another way, or a couple of other ways of doing this. One, we can, rather than using degrees, minutes, and seconds, you can also just use degrees, minutes, and some decimal value to equal the seconds. So if I come down here, for instance, 20 degrees 32 minutes and 10 seconds north can also be expressed as 20 degrees 32.17 minutes north, and I got that because 10 out of 60 seconds equals, and I've rounded to the nearest 100ths, equals 0.17. So 32.17 degrees north, and 080 degrees 15 minutes and 27 seconds west can also equal 080 degrees 15.45 minutes west. And I got that because I got that because 27 divided 27 into 60 is 0.45 of a minute. And the last way that you can express a coordinate is with just in degrees. So this could also be expressed as 20 degrees. Oops, let's just say this. It could be expressed as 20.536 degrees north and 080 degrees 080.22 258 degrees west. And I got that because 32.17 divided by 60 equals 0.536 when you round it. And also 15.45 divided by 60 equals 0.258 when you round that. So that's the way I converted from degrees, minutes, and decimals to just degrees. So that's an overview of the lat-long grid and the way that you express coordinates.